2 years from now, I may want to use this one. Okay. In fact, when I finish with this paper, I'm gonna send it to a conference, and early April, I'm gonna make a presentation. Obviously, in the 4 months from now, then, if I don't do things right, I may forget what those things were or how to do it. But now I'm doing it. Even me, ignorant, 4 months from now, will be able to do it. Okay? That's why I actually have little notes in those cells. You can insert the note into a cell, and you can set it up so that it shows only when you hover on that cell. These are messages in a bottle. Okay? It's a message to the user. This is the green light for GoSeek to run as soon as one of the inputs change. If you're setting up on the problem, you want on the left-hand side value, make sure it's red. Now you know what it does. But I set it up so that a double click is toggled between possible values. Anyway, I'm in this setup mode now. So I want to do the following. Whether it's future value or present value, look at these equations. There are 5 things here, okay? There are 4 things in this case. I'm going to kind of make it a little bit more general, but for now it's 4 things. Present value, future value, interest rate, and length of time. So algebraically speaking, if you knew 3 of them, you could find out the 4th. Sometimes that's easy, sometimes it requires something like natural logarithm to do those equations. It's not difficult. I mean, if you wanted to figure out how long it would take you to double your money if you're earning 10%, so that precise calculation requires natural logarithm. By the way, if you want to know that approximately, there's something called rule of 72. Approximately speaking, so if I'm going to do 10%, divide 72 by 10, approximately it's going to take you 7.3 years to double your money. If you're going to earn 24%, that happens only in 3 years. Approximately, it's not exact. But if you want the exact number, you're going to have to do some algebra. But the trouble is, you can do it, and there's even an Excel function to calculate it. It's called MPEG. There's a function to calculate the unknown rate, you know, the present, future, and the time period. Why do I need separate template for all of them? You could. And you need to have a template for the future and for the present. So we're talking about 8 different setups. Well, we're going to be civilized. We're going to do it in 1 page. And here's how we're going to do it. First, we're going to use this option, okay? If that is green light, I'm going to make it into future value. So, given the money now, you figure out how much money you're going to have in the future. Otherwise, if I tell you how much money you're going to have in the future, you're going to figure out how much money you have now. That's a present value problem. So on the tag, I'm going to do the following. If this little thing, or as they say around here, if this little thing is equal to 1, make that a future value problem. Otherwise, present value problem. So it's future value now. If it's anything but green, it's present. I mean, I could have made it on the on and off option, but I wanted to make this general enough so you could have on, off, or in between. Okay. Oh, there is one more thing with respect to interest rates. Interest rates are quoted on what we call APR rate, which is short for annual percentage rate. For example, if you just get a credit card and it says 18% APR, that means you're paying 1.5% a month. Okay? It doesn't amount to compound. APR is you multiply the periodic interest rate with the number of periods in a year. So if you're doing monthly, that's 12. If you're doing weekly, 56, and so on. But that's how the rates are quoted. If you want to compare different rates with different compounding frequencies, you should compare them based on what we call effective annual rate. But in any case, our formulas change like this. Future value at time t is equal to present value 1 plus, for some reason this is slow, APR over F raised to the power T times F. Here is equal to number of years. It'll be easier to line it like this. Frequency of compounding. Number of years, and that number does not have to be a whole number. It can be 7.5. Okay? And R is equal to APR divided by F. That's the periodic interval. So that you can handle things that are monthly, daily, annual, without worrying about it. So in that sense, whether I'm dealing with future value as an end result or present value, I have now 4 inputs. The APR, either present or future, depending on where I start. Length of time in years and compounding frequency. So I'm going to go to my little sheet. I have only one input right now, so I need to add inputs without actually screwing anything up. That's why I set these things up as tables. And this little green plus button adds a row to that table. It also shuts everything down. There's a little macro behind it. It's not very complicated. Okay. And, okay. My inputs are gonna be APR. I'm going to be smart. I'm going to, come on, format it as percent, and I'm going to put 1, 2, 3 digits. Again, it's by sheet. I choose 3 digits. If you want to use 2, it's your business. You know, the golden rule in this class is, it's my sheet. I can do whatever the hell I want. If you don't like it, you do it yourself. That especially applies to colors. You probably realize that I don't have much sense of aesthetics. There's a good reason for that. If I had, I wouldn't have been teaching this. I actually aspire to have zero sense of aesthetics. Let me put it that way. Now it's in, well, let me also zoom a little bit on this. This my old eyes. That's why I put those buttons in there. Again, it doesn't do anything complicated. It just does it in increments of 5%. It just changes this number, okay? Suppose I want to enter 10%, 10.25% into that cell. Decimal wise, it's 10.25, right? Well, you don't have to remember that. Just enter 10.25. Done. Right? There's only one thing you need to be careful. If you're going to enter a number that is less than 1 in absolute value, do not write it without the leading 0. 0.25, it actually sees that as 25%. But 0.25, that's just 0.25%. Okay? Other than that, you're fine. Now, who cares what 0.005% is? Again, if you can do it, fine. I view that as a parlor trick. For example, I can square numbers that end in 5 in my head very quickly. Because I have a little rule. Square of 35 is 12.5. It's the first number multiplied by the next number added 25. Okay? Some older kids taught me that way back when I was in second grade. I can do that trick. I've been doing that trick since I was in second grade. Oh, you're so smart. No, I just have to know the rule. But who cares? I can do it here now, right? All I have to do is set up the equation and enter 35. I'm done. What's the difference? Of course, since I know all these tricks, I'm still probably faster than you guys. But you guys haven't seen that. I wasn't allowed to use a calculator until my junior year in college. I took a math stats class without being allowed to use a calculator.